Today's lecture is going to be a little different. So we've talked about parental care under normal circumstances in birds where parents take care of their young. But in some cases, parental care involves individuals taking care of young that are not their own. So this is the topic of brood parasitism. One part of that. We'll talk about another case of that, a different type of situation where individuals take care of young that are not their own, that is not brood parasitism. But we're going to focus on brood parasitism today. So brood parasitism is the behavior in which a female will lay her eggs into the nest of another individual to try to trick that individual into raising their young. And we'll talk about this being both intraspecific and interspecific. The picture I have here is a case of interspecific brood parasitism in which one species, the brown-headed cowbird with the larger brown eggs here, has parasitized the nest of a prothonotary warbler. So as I mentioned, sometimes this is intraspecific and sometimes interspecific. Intraspecific brood parasitism, as the name implies, is when an individual parasitizes the nest of another individual in its own species. And this is fairly widespread. It's seen in different species in 16 different orders of birds. It seems to be more common associated with colonially reproducing species. And that kind of makes sense if you think about it, because in a colony, there are more potential targets available for a brood parasite. So a female may nest herself and try to supplement her fitness by laying a few extra eggs into the nest of other individuals in the colony. Or if the female, her nest fails, but she hasn't completed her clutch yet, if she doesn't have time to re-nest, she may, again, just dump those eggs into the nest of another individual in the colony. But by having a colonial situation, you just have more potential targets in the area. So one example of this is seen in American coots, in which 41% of nests in one study were intraspecifically parasitized. We saw this behavior very commonly in blue-tailed bee-eaters in Taiwan. And the host during this time period will closely guard their nest, their own nest, to try to prevent individuals from sneaking in eggs to their nest. And there was an interesting phenomenon every morning when we would come to a colony. There would be a bunch of eggs that would be dumped out at the kind of the base of the colony. And this is coming from two potential sources of behavior. One is if a female has prepared a nest, but she hasn't actually laid eggs yet, she will go into the nest and go, wait a minute, there's an egg here. That's not my egg because I haven't started laying yet. So it's clear that she has been parasitized. She could kick that egg out and it would roll out at the base of the colony. If, however, she has already started laying her eggs, there is a potential that one of her eggs could be kicked out as the parasite sneaks into the nest and it lays its own egg, but it takes one of the host eggs and kicks it out to maybe maintain the appropriate clutch size or to hide the fact that the host has been parasitized, so that that deception is maintained. As a side note, I was involved in this project in Taiwan for a number of years, and one of the things that we talked about was it's kind of sad that these eggs are being dumped out and there's no chance that they're going to survive. And I was thinking, well, probably some of them are still viable. And so we actually did take the eggs and incubated some of them and found out that they were viable and you could raise the young. And we use this knowledge to talk with my colleagues in Taiwan, talking to the zoo in Taipei about establishing an exhibit of blue-tailed bee-eaters using these eggs. And sure enough, they now have a captive population that came from these abandoned eggs. So it's a pretty cool story. And it's apparently a very popular exhibit at the zoo now. So Dr. Xiaowei Yun is the one that was leading this effort. Okay, so that's intraspecific brood parasitism. Interspecific brood parasitism is when one species parasitizes another species. Now, in some cases, this is facultative, meaning that the females of that species can build their own nests and may typically do so, but interspecific brood parasitism is a way that they could supplement their fitness by laying additional eggs into closely related species that happen to be nesting nearby as well. But they're not totally reliant on the brood parasitism as their only mean of fitness. So one example of this are canvasback and redheads. Redheads are a interspecific brood parasitic species. They will, sometimes the females will lay her eggs into the nest of a canvasback. And interesting, these species both look very similar in their plumage. Their eggs are similar as well, but you can tell that a parasitic event has occurred. If you look at B in this figure here, the egg indicated with the arrow, slightly different coloration, but it's also slightly smaller. And that is an indication that it's a redhead egg that has been put into a canvasback nest. Another example of facultative interspecific brood parasitism are yellow-billed cuckoos. Yellow-billed cuckoos typically build their own nest, but occasionally, again, a female will parasitize a close related species of the black-billed cuckoo in areas where they overlap in range. But now I want to focus on interspecific brood parasitism that is what we call obligate. And this is really bizarre if you think about it. This means that a species that is an obligate interspecific brood parasite is totally reliant on another species to raise their young. Their only form of reproduction in gaining fitness is by parasitizing other species, the host species, and tricking them into raising their young. And this can lead to some really bizarre circumstances as pictured here. The small bird on the right is a dunnock, a hedge sparrow, and the large bird on the left is a fledgling common cuckoo. And the size discrepancy there is just amazing. And we'll talk a little bit about the fact that once it gets to this stage, it's almost like the host parent turns into a little robot and can't help but feed this young that is clearly not of the same species. But it's like they can't realize that. They have this open mouth in front of them that's begging. It came from their nest, so they're going to shove food down its throat. So how could obligate interspecific brood parasitism evolve? One hypothesis that seems to make sense is that it has evolved in stages, with first intraspecific brood parasitism, where individuals of the same species may parasitize each other. And if this increases their fitness, then it will be a selective advantage for this behavior to develop. And if you happen to then be nesting near closely related species or species with similar nesting biologies, then you can also maybe supplement your fitness by sneaking a few eggs into these nests as well. And then once this becomes so adaptive, you might begin to be making so much of your fitness gains from sneaking your eggs into the nest of other species that it pays to actually invest more into that strategy and give up on your own nesting attempt, which could lead to the obligate interspecific brood parasitism tactic and behavior. So let's talk about some of the behaviors associated with making this an adaptive behavior. Well, first let me give you the examples of species that are obligate interspecific brood parasites. It's really not that common, as you can expect, but it has evolved a number of times in a number of different groups. One species of duck, the black-headed duck from South America, is an obligate interspecific brood parasite. They parasitize other species of ducks, coots, ibis, gulls. All of these share in common, again, similar reproductive nesting biology and the fact that they're producing altricial young. So it really has little impact on the host in this case. The ducklings that are hatched into the nest of a coot, like this middle picture here, it really doesn't have any effect on them because they don't require any parental care, and the ducklings leave shortly after hatching. So this is one of those rare cases in which the brood parasitism is almost like a commensalism, really. The hosts are not really impacted, but the parasite, or the almost commensal in this situation, is benefiting by having the host raise their young. In most cases, we'll see brood parasitism truly is brood parasitism, in which the host is significantly showing reductions in their own fitness, so by having to take care of someone else's young. Honey guides are old world cavity nesters found in Africa. There's 17 species. And well, they're not the nesters. They actually parasitize the old world cavity nesters. So they're found in Africa, and that's the host that they specialize on. We talked a little bit about honey guides throughout the semester, about like their diet specializations and some of their interesting behaviors. But they're also, another interesting behavior is their obligate intraspecific brood parasites. Cuckoos vary. There are two major clades of cuckoos. The old world cuckoos are all parasitic. All of the species are parasites. The upper left picture here is of a common reed warbler feeding a common cuckoo nestling that's in its nest. And you can see that the nestling is so big it even barely fits into the nest. And the poor warbler is just completely naive to what's going on, and is continuing to raise this offspring that doesn't look anything like its own offspring would have looked like. On the right, we have a New World cuckoo. The neomorphine cuckoos, the New World species, don't show nearly as much parasitism. It has evolved in 3 out of 33 species. Also in Africa, there are the Bedouin finches, the indigo birds, and the whitas, like the long-tailed whita, and the parasitic weaver. These are also parasites, oftentimes, of astrelid finches. Another New World case, the main New World case of obligate interspecific brood parasites are cowbirds. The family of cowbirds has 6 species, and they 5 of which are parasitic. They're all found New World. 2 of them, one of them is very common in North America. The upper right here is the brown-headed cowbird. You can see these very commonly in areas that are edge-like habitats near forests but are open, or in open habitats themselves. South Central Texas is getting larger and larger concentrations of this bird with this brilliant red eye. This is the bronzed cowbird because of this bronzy appearance. And then the shiny cowbird is primarily a South American species that has invaded the Caribbean and has recently established populations in South Florida. All right, well, let's talk about some of the adaptations of an obligate brood parasite that would make that transition so that you're so successful at doing this that you give up on laying your own nests. Well, one of the things, if you're not having to use that time and energy to make a nest and guard a nest and incubate, you can spend more time foraging, and you can use more of your energy to just produce more eggs. So females of these species oftentimes produce more eggs of comparably sized birds or close related birds that are non-parasitic. Brown-headed cowbirds, for example, on average can lay 30 to 40 eggs per season, which is just outrageous. That's a huge number of eggs. And actually, one in captivity, I believe, actually laid 60 eggs. So this allows you to pick potential host, lay an egg, and then move on, lay another one, then lay another one, and really spread these out. And Some of them are going to fail, but there's a good chance that some of them will succeed. And this allows you to avoid what's called the predation jackpot. You've heard the term putting all your eggs in one basket. By spreading your eggs out, you're not putting them all in one basket. So if one nest is depredated, it's not that big of a loss because you've got eggs in many nests in the community. Another thing that parasitic species oftentimes do is they pick on smaller host species. So the picture on the right here is the picture of the larger, browner eggs here, the brown-headed cowbird, and the smaller eggs, or the reddish coloration, or the prothonotary warbler eggs. There are many reasons why this is advantageous. The cowbird eggs, when they hatch, they're going to be bigger and have the potential to outcompete the host nestlings for food. But even before then, we'll talk about what some of the potential host responses are to reduce parasitism if they recognize that they have been parasitized. One of the obvious things you could do is just grab that egg and chunk it out. Well, if your mouth is just too small to be able to wrap around that egg, you're not going to be capable of doing that. And so that's one of the advantages from the cowbird's perspective, or a parasite, in this case a cowbird, parasite's perspective, an advantage of picking on someone smaller than you. They just may not be able to grab your egg and throw it out of the nest. So you may think, well, why didn't the host just recognize that and destroy it by pecking it? And studies have indicated that this actually is not a good thing for the host to do, because cowbird eggs and parasitic eggs and other species tend to have thicker eggshells, such that if the prothonotary warbler in this case was to peck at one of the cowbird eggs, there's a chance that their bill would glance off and actually strike their own egg and do more harm than good. So the cowbird egg would still be maintained in place, but they would have poked a hole in their own egg. So that's kind of defeating the purpose. Now, cuckoos do a very interesting thing. Now, cowbirds don't do this, but cuckoos are well known for producing mimetic eggs. So a host female throughout her life only parasitizes one species of bird, and she does so that she can maintain an egg that looks very much like that of the host species, to trick the host into raising their young. There's been a lot of coevolution in egg recognition of the host of common cuckoos to say, hey, that's not my egg, it didn't look close enough, chunk it out, because they do have that capability, or to abandon the nest entirely. So there's a strong selection pressure on the cuckoos to do a better and better job at, there's eggs that are better mimics tend to have higher fitness, and so that trait evolves in these populations to become better and better mimetic, what we call egg races. So here are two of these examples here. I wouldn't have been able to tell you if it wasn't for the arrows, but the arrows are indicating the parasitic eggs of either a great reed warbler compared to the host egg color, and the redstart on the right. You can see there's a clear size difference in the redstart, again picking on a smaller species, a larger cuckoo picking on a smaller host species. Well, this is kind of bizarre when you think about it. How can different females have these adaptations, a genetic-based heritable adaptation to parasitize just one species? How is that maintained in a population if they end up mating with males that may have come from a female that had another set of adaptive genes? This was thought maybe it was positive assortative mating, but that could lead to very rapid diversification and increased speciation of different common cuckoos into multiple species. Well, it turns out that the female doesn't have to worry about mating with a specific individual male, because the mimetic genes that give them this capability of mimicking one species or another, they're found on the female W chromosome entirely. So there is no potential to get mixed genes from the male. One of the things that the adult parasites do to increase the chance that their eggs are going to hatch and outcompete the young is they remove one of the host eggs. Again, I mentioned this in the case of intraspecific brood parasitism with bee eaters. Again, this can maintain some deception to make sure that the host doesn't realize that it's been parasitized. It may also maintain an appropriate clutch size. Remember, the host female is going to have to incubate these eggs, and if there's too many eggs dumped into this, that may cause an inability for all of the eggs to hatch. So that wouldn't be a benefit to the parasite. And the other thing is, just by removing that host egg, you're just reducing the competition with your parasitic young when they start feeding the young. But we'll see that there are some other ways that the parasites reduce the amount of competition in the nest. One is they just have faster rates of development. Brown-headed cowbird eggs grow really, really fast. They hatch. They take fewer days of incubation. Parents sometimes can time the development of the initiation of development as well to kind of give their nestlings a head start. So the cuckoos, for example, we talked about how live birth isn't capable because the host female's internal body temperature is just too high in most cases compared to the appropriate incubation temperatures. But cuckoos may actually just a few hours begin the incubation process before they lay the eggs into a nest. And again, that just increases the chance of picking a host nest that you time it such that your young hatch first so that you can outcompete them for a food supply. Or in the case of the cuckoo, we'll see if you hatch first, there are other ways of taking care of your competition. Again, by picking on smaller species and hatching first, if you develop a larger host nestling, then you can just simply out-compete. When mom and dad come in, the stepmom and dad bring food to the nest, you can out-compete your step-siblings just because you're bigger. You can dominate them and get all of the food, and this is what brown-headed cowbirds do. They basically cause their nestmates to die of starvation because they get all the food. Cuckoos, however, they outcompete the competition by getting rid of it before they even hatch in many cases. So if they have hatched first, they, even in this incredibly altricial stage where they're blind and relatively immobile, they're strong enough that anything that touches their back, they push out of the nest. So this could be any very small nestmate that may have hatched just in the same day or maybe hours prior, or any egg that hasn't hatched yet. They just roll these suckers out of the nest, even though they're completely blind at this point. So it's really pretty fantastic behavior. The Greater Honey Guide, what they do is they have these really sharp tips on their mandible. As you can see here, they kind of look, it's kind of hard to see it, but if you see illustrations of these sometimes, they look like ice tongs, really nasty hooks. And as soon as they're born, they just do this. They just like constantly moving around, chomping on anything that they can get their bills on. And that would include any of their step siblings who they end up killing or actually potentially crushing competitive eggs. Once they hatch, again, if there are any competing nestlings in cuckoo nest, if they've hatched a little bit later than the optimal time, they may have to compete with their young, with their step siblings. Oftentimes they're just more aggressive though, and they can outcompete them for food. And we mentioned how the brown-headed cowbirds, that is their main strategy. But to increase the feeding rate of the parents, they do some other ingenious things like imitate the nestling vocalizations of the host to increase the feeding rate. And in some cases, some species of cuckoos, a single nestling can make it sound like they're an entire brood of the host species to increase the parent's feeding rate. In some cases of the Bedouin finches, they will imitate the really bizarre, very specific mouth patterns associated with their host nestlings to, again, try to maintain that trickery in the nestling phase to the parents to feed their young. So this is a purple indigo bird showing you this pattern of high contrast and also highly colored patterns that there's a lot of coevolution between the parasite and the host nestlings. So what are we've been talking about the adaptations and that it lead to increased fitness associated with a parasite, but what about the effects on the host fitness? Well, it can significantly reduce host immediate fitness in many cases. In many cases, if you're parasitized successfully, you have absolutely no reproductive success. You don't raise any of your own young that year. In this case right here, we've got a brown-headed cowbird nestling on the right, a Wilson's warbler here on the left. See the size discrepancy here. That's going to take an immense amount of energy and time on this individual to raise something that they're getting absolutely no fitness for, and can actually decrease their probability of survival in a healthy state into the next year. But again, that could be just you lose fitness associated with 1 year, maybe no different from like if a snake had eaten your young. The real impact on lifetime reproductive success depends on the population's level predation rate. So what is the frequency of parasitism? If it's a very low chance, again, it's no different from just being depredated, your nest being depredated. But if in some populations, parasitism rate by cowbirds are higher than predation rates, and can lead to complete loss of fitness and a significant decrease in lifetime reproductive success. This is particularly problematic for endangered species. And so a lot of, besides just maintaining appropriate habitat for golden cheek warblers and black cat vireos and Kirtland's warblers up in Michigan, there's also a huge effort into reducing the number of cowbirds in these habitats. This is an extremely costly, time-intensive management strategy, but it really is key in some populations. As you can see here from this study on golden cheek warblers, showing that when you remove brown-headed cowbird females, if you look at the parasitism rate, which is shown by the squares here, it's much lower. As you reduce your effort to remove females, parasitism rate increases. Again, so there's a big inverse here. Low removal of female, you're going to have higher parasitism rates. Increase removal of female, you get a decrease in parasitism rate. So that can be literally by taking brown-headed cowbirds out, by trapping them, by shooting them. But again, that's not sustainable. The best thing to do oftentimes is to change the habitat away from preferences that brown-headed cowbirds like. They like edges, don't have a lot of edge habitat, or open habitats. So by making changes in the basic habitat, you increase the efficiency of some long-term beneficial trends for the management of these species. So what can the host do if they are parasitized? Well, some are rejectors. So again, if they're big enough, they can throw out the eggs. In some cases, they can destroy them, but I talked about how that's dangerous because of the thickness of the eggs. One rejection strategy is to simply cover over the eggs if you've been parasitized and start again. So this is a photo of a nest that I discovered when I was doing some undergraduate research in San Angelo, Texas, in which this was I can't remember if it was a cardinal or a pyroloxia nest, in which the birds nested and then got parasitized, and they went, shoot, build another layer over top of that, lay in another egg, got parasitized, And so this happened 1, 2, 3, 4 times until they finally just went with it. But you can see here that this larger egg is another parasite egg, and the host eggs are here. So regardless of all that effort, they ended up getting parasitized anyway. So that's one thing. The other thing you do is if there are other sites or other nest potential, you can just abandon that nest and just start over from scratch. And that might be better because then you can actually hide the location of that nest and hide from the parasite. But again, that depends on availability of nest sites. Open cup cavity nesting species, that might be more likely. Secondary cavity nesting species like prothonotary warblers, there just may not be many other cavities available, and so they may be more likely to just accept in those circumstances, which that's the next thing. So some species just accept parasitic eggs. And that may be because they just don't have any other options, like we mentioned with the prothonotary warbler. There just aren't any other cavities to start nesting again, so you just have to try to nest if this is the case. In other cases, it appears that the hosts don't recognize that they've been parasitized. This may be because of mimicry, but it also could be they don't have a long enough coevolutionary history with parasitism. Brown-headed cowbirds historically were restricted to the Great Plains area, but with deforestation and cattle management to changing habitats, the brown-headed cowbird is throughout North America now. And so it's come into contact in ranges with new potential species that don't have any coevolutionary history with brown-headed cowbirds. And so their lack of response may just be due to a time lag in adopting some type of effective rejection strategy eventually. Okay, so that's a brief summary of some of the issues associated with brood parasitism. We'll talk next time about another kind of weird deviation from typical parental care called cooperative breeding.